testing the API. So it has three, like this is the Swagger UI that was generated by the Fast API. And so here it has three endpoints: the health, which shows the health of the API if it's working correctly. Um, so let's try to predict and see if it actually is the model is working as it should be. Let's try it out. We choose, maybe we change something here like the year, because the range is in 2015 to 2007. But first, let's first usually like execute to see if it makes predictions. As you can see, the predictions are here. So it made the prediction. So let's try to see if, what if we put it out of range? Maybe the set parameters, because the set parameters is from 2007 to 2017. Let's put this to 1999. Let's see if it's going to bring an error. So you can see here there is an error which is showing greater than equal. Input should be greater or equal to 2007. You see, this is the limits we set, so it's showing an error because the model doesn't go beyond those limits. There is no data beyond those limits in our data set. So we can go ahead and retrain the model here. We can see what if maybe the dataset has been changed or updated. Let's see how it happens when we try it out and we try to retrain it. So we choose the file here. We dataset here, select, and then we execute. We click the execute button to retrain. Wait for a little bit. So we can see that it generated some stuff and it's pinning the models against each other, the random forest, the season tree, and the linear regression. So it worked, and by far we're finding that the lowest MSC, which is the mean square error, is the random forest model or algorithm, which is the one we're going to keep using for our specific app.
This is my mobile application which holds a dataset which has it calls the data from the model in the Fast API backend. So for us to test it, we choose a random country, let's say DRC, right? It has some preset variables like country, year, and country code that I recommend. You don't change the country code, the longitude and latitude. And it has like this specific app has 26 input fields, which are divided into 8 sections, which are country and year, disease indicators, water services and sanitation services, population, basic sanitation, and geography. So when you want to predict, you just maybe you there are some already preset variables. Just click the predict button, as you can see, and then we wait. Here it has the 30% population affected, which is high risk. High risk has red. The Let me change something so you can see how the low risk as well works. The low, okay, 90%. You can see the low risk is green, and the medium risk, hold on, let me put in 60. Medium risk is orange, as you can see, the moderate risk, yeah. So you can change even the country and just preset variables change based on the dataset we have, and we predict. It's always going to update the predictions when we click the predict button. It parses from.
So let's go ahead and start showing the ML model that we made. So we start with the loading the data. Let's just go ahead and go to the most important parts first. So the visualization here is where the feature correlation is shown. This is where the strongest indicators of the strongest incidence correlators are. So the factors that mostly correlated with incidence of malaria are, so the strong red, the higher the positive correlation, and the blue is the protective effect, which is mostly positive, which shows the little to no correlation. So let's go ahead to the loss curves. So on the loss curves here, we see that after training all three models I plotted curves for both the train and the taste data. The random forest has the least to the long, like the most stable loss. So there is no overfitting on it, which is why we chose it to be the better one. Here we've seen where we compare all the models, the decision tree, the random forest. And here we can see the mean square error. We can see the random forest has the least one, which is more ideal when we're doing machine learning. And here we show a scatter plot, but each one you can see, like here it's very spread because usually linear regression isn't good with missing values and non-numerical data, which is why you can see that random forest has a better spread on the dotted line, which shows it's better. And this is my notebook, and thank you for. So we were asked to answer some questions like, is your loss high or low? What can you do to further reduce the loss based on your use case? My loss is very low. The R squared of 0.98 means the model explained 98% of the variance. To reduce it further, I could collect more data beyond 2017 as my current data set only reaches 2017 and add some other factors like rainfall and temperature, which are non-malaria drivers. And for the second one, are there parameters that can help improve the performance of your model? Yes, for the random forest, the key ones are n and estimators, the number of trees. I use 200 and the max depth, which controls the tree complexity. I use 10. So for the decision tree, it's more like max depth and minimum sample split, grid search, cross validation could find even a better combination. And what could happen if you had new data? I already built a solution for this in the retrain endpoint, which helps you retrain the data. And model sells the lowest MSE, and then no redeployment needed, no downtime. And what was the basis of how you configured the chorus middleware? I avoided the wildcard asterisk, which would only allow any website to call the API. Instead, I whitelisted only two origin, the localhost for development, and 10.00 for the Android emulator. I also explicitly allowed method headers and credentials. You only allow what you explicitly trust.